Welcome to this ASQ Webcast event. I'm Pablo Baez with ASQ. Today we have with us Duke Okes. Duke has been in private practice for more than 25 years, helping organizations implement systems for managing and measuring quality and diagnosing process problems. Prior to this, he worked for TRW Automotive, where he was involved in troubleshooting equipment and product problems. His academic degrees are in electronics, business, and education, and he has taught statistics and management research methods for business and technology majors. He's the author of Root Cause Analysis, the core of problem solving and corrective action. He's the developer and primary instructor for ASQ's public course on root cause analysis, and he's an ASQ Fellow and certified CMQ, CQE, and CQA. And today he's graciously offered to share his presentation titled, Getting the Defects Out of the Root Cause Analysis. This overview will touch on everything from the terminology and steps of root cause analysis to the human side of creating a culture that sees this as a learning process. So without further ado, let me get out of the way here and pass the microphone to you, Duke.
Thanks, Pablo. Yeah, I sort of feel like I've dedicated almost 100% of my life to root cause analysis for the last few years. Getting the defects out really just has to do with finding some of the sort of core problems that I've seen across many organizations that I've worked with, struggles that they have. And so that's what I'm going to talk about and some ways to approach that. And this slide is a good way of summarizing sort of where I think we are since about, let's say, 1992 or so, at least in the U.S., earlier in the U.K. There have been many companies implement standards such as ISO 9000, TS 16949, ISO 14000, et cetera. And so these help them put in a good basic quality management system. As part of that system, though, they have to have a corrective action process that deal with complaints, product issues, process issues, and so on. But unfortunately, many organizations don't really know how to do root cause analysis or effective corrective action very well. So although they're taking actions or putting solutions in place, a lot of times those solutions just don't work, and they're frustrated. And so I've seen a lot of interest in this topic, and it's one of the reasons that I developed the course for ASQ. I wrote the book and so on, and do a lot of speaking and write a lot of articles on the topic. Here's what I like to talk about, and it looks like a lot, but it really isn't, and much of it is what people are going to be somewhat familiar with, and I hope I just sort of help them fine-tune their understanding of it. So first of all is make sure we understand some of the core terminology involved in root cause analysis, that we understand the different types of causes that we could be dealing with when we do an investigation. We could always take an investigation to a deeper level, and so one of the keys is to know when we should stop. One of the more simple, if you will, issues that we run into is people simply don't define the problem clearly, and so they end up wasting a lot of time. So that's a very important part. Identifying possible causes. A lot of people use perhaps cause and effect diagrams. And that's one tool, but there are many other ways to identify possible causes. Collecting and analyzing data, we won't spend a lot of time on that because that's a very in-depth topic, but it's a key issue, obviously. Where's the evidence to support the causes that we found? We'll also talk about making sure that people have enough time to do an investigation, and that the culture, as Pablo mentioned, is one that supports effective corrective action. So let's dive into first talking about the terminology. And I'm using terminology as based on ISO 9000 that says there are three things related to taking action to keep problems from occurring, or ways to respond to a problem. One is to correct the problem, and this involves simply doing containment and remedial action. This makes the problem go away, but does not have anything to do with the causes. So containment and remedial action is very often identifying what units, if you will, are defective and finding whether or not we're going to repair or replace or scrap those units. Corrective action is the action we take to actually eliminate the causes of the problem. Now, one of the keys is that we in some cases, should simply correct the problem and not necessarily worry about going after corrective action. So we'll talk about some examples when we might do that. Then preventive action, and I sort of worded this in what I consider a humorous way, is that's the action that we should have taken before, and had we done that, we would not have had this problem. There's a lot of confusion about what preventive action is, and so one of the things I like to do is differentiate between preventive action to keep the problem from occurring as opposed to preventive action that a lot of people call it that keeps problems from recurring. Real preventive action is to keep a problem from occurring in the first place. Now, I talked about this. Sometimes all we will do is correction of the problem, or we may not actually take corrective action. That is, we may not actually try to find the cause of the problem. And here's an example. Suppose I have a laboratory that generates reports, and someone uses those reports in order to generate a certificate of analysis that is sent to the customer. During an internal audit, we found that there's a lab report that wasn't signed, but yet someone had used the information in that report to generate a certificate of analysis, and that's not in compliance with the procedure. Well, correction would be, okay, how many other COAs have we issued where the lab report had not been signed? That would be containment. The remedial action would be having someone sign those reports if they should have been signed. If they shouldn't have been signed because of a problem, then our containment and remedial action may need to also involve going out and letting people know about what we might have shipped or issued under these COAs. But suppose that we find that only one lab report had not been signed out of maybe 30 that we look at. Well, in that case, we might say, well, gee, you know, it should have been signed. Somebody just forgot to do it. They went ahead and issued the COA. And so what we're going to do is close out this problem or this nonconformity without taking corrective action. And that would be an absolutely appropriate action to take if it's not a serious risk and or a high frequency of the problem. So to summarize, we might do correction in some cases and not bother implementing corrective action. Now, if we are going to take corrective action, then we need to figure out what the cause of the problem is. And I've listed here 4 different types of causes that we could find during an investigation. Direct cause is that thing which sort of is immediate in that it caused the problem to occur. So if I have a flat tire, for example, the nail in the tire would be the direct cause. The system cause is the reason that the nail got in the tire. So in the case, let's say, of our certificate of analysis or our lab report not being signed, the direct cause might be that the person simply forgot to do it. They were in a hurry. The system cause might be that they got several lab reports and need to issue the certificate of analysis at the end of the day before shipment, and they were just trying to handle too much at one time. And so overloading, if you will, the system by having them trying to do too much too late in the day may be the system cause. We might need to look at how we allocate time or resources to this particular task. So the direct cause is what actually caused the problem. The system cause is the reason for the direct cause. So when we're doing an investigation, we first need to find the direct cause, and of course there may be more than one of those. And then if we decide that this is a really serious issue and we want to make sure it never ever happens again, we may also want to go after the system cause. Now there are other things that we might call contributing causes that are things that didn't actually cause the problem, but they may have facilitated it. That is, they contributed to it in some way. Whether or not you do something about the contributing cause will depend very often on whether or not it's something over which you have control, whether or not it's likely to be effective, the cost of that, and so on. We really need to work on the direct cause and the system cause and do the contributing calls if we think that's worthwhile, but not focus only on contributing causes at the lack of working on direct and system causes. Now, detection, what I mean here is that we have, let's say, an inspection or a review process that should have caught this particular problem, but it didn't. Well, that didn't really cause the problem. It instead allowed the problem to propagate, if you will, get further through the system. All too often I see that organizations want to add an additional inspection or an additional review of some sort in order to implement corrective action, but they need to keep in mind that that will not prevent the problem from happening. It may keep it from getting as far into the system, but it is not going to really deal with the cause of the problem. So the direct calls should be our first focus. System calls, if this is a really important issue and has recurred several times, and we want to go deeper. Contributing calls, if there are contributing causes that we think might have some impact on the probability of this occurring. And detection causes, obviously, if it contributed to the problem in the sense of allowing it to get through the system, we might want to work on this, but we should not do that without also working on the actual cause of the problem. I have then a problem here, an example of a problem. So in this case, we found that someone had worked to the incorrect addition of a procedure. So someone is performing a task, and the procedure they're performing that task to was not the proper addition. And so if we do an investigation, we might find that the database from which they pulled that procedure still had only the previous edition of the procedure rather than the current edition. And so that would be the direct cause, is that the database is incorrect in what it holds. However, there's a reason why that database doesn't have the correct procedure in it. And so if we dig down to the system calls, we may find that the process that they use in the organization for moving the procedures from the change or editing database into the working database doesn't clearly specify who is responsible for doing that and when it should be done. That is, maybe there's not a specific trigger that makes sure that it gets done at the proper time relative to when the training was done or when the engineering change became effective or whatever. So working on that will make sure that we don't have an incorrect addition of the procedure in the working database in the future. If we work only the direct calls, what we're going to do is to put the current addition to procedure in the direct database, and that will address it this time, but it may not address it in future cases. Contributing calls in this case might be that this particular procedure was a calibration procedure that had been changed in response to a recommendation by the equipment manufacturer. So the type of device we're calibrating, we got a recommendation from the equipment manufacturer to do a somewhat different process for calibration, and so we had changed that procedure, but since it wasn't an internally initiated change, but instead came from the equipment reviewer, or sorry, the equipment manufacturer, we simply didn't do the same normal internal review process. And that then may have contributed in the sense of people were not as aware of the fact that this change was taking place, especially the people who were supposed to move it from the change database to the working database. Then the detection example. A lot of people would say, well, you know, had the worker looked to see what the latest edition of the procedure was before they used it, this problem would not have occurred. Well, we actually don't know that because we don't know whether the master list was up to date or not. But let's assume that it was. If the worker didn't check the master list, then it's true that that would allow them to use the incorrect addition. However, it doesn't cause it. In addition, if the procedure doesn't require, or if the organization doesn't require that a person check the master list, then this can actually be given as a cause. However, it might be given as an additional step to add to prevent the problem in the future. However, I don't think that's a good use of time in many cases, or especially in this case. I'd instead rather work on the direct calls and the system calls and only put a detection step in if I believe it's still likely to happen in the future. So again, there are all these different types of calls we could run into as we're doing an investigation. We need to be clear about putting our effort into the ones that really can prevent the problem from occurring in the first place. Now, I mentioned earlier that for some situations we might only do correction and not do corrective action. But even if we do corrective action, when we do root cause analysis, there are many levels that we could go to. So when you hear about the 5 why process, for example, asking why 5 times, well, 5 may be enough, it may not be enough, it depends on the problem. So the question is, when do you stop? And so one of the issues that I like to think about is we should always consider risk as well as frequency and cost as one way to decide how much deeper to go. And so at the bottom of the slide, I have 3 examples here. If I have a single occurrence of a very low-risk problem, we may stop with occurrence, as we did earlier with the COA and the unsigned lab report. However, if the problem has occurred more than once, or it's what we consider a medium-risk problem, then we might say, well, let's find the direct calls and fix that, but let's not necessarily try to go to the system calls. But if it's a more serious issue, then obviously we do want to go to the system level. And in most organizations now, there is a risk management process of some sort, and you'll find especially that the financial auditors will have such a system. And so we need to consider developing something similar for our corrective action process, some way of assessing the risk for each the risks related to each problem, and let that help us determine how deep, how much time, for example, we're going to go with our investigation. Now let's talk a little bit about the process of root cause analysis. I've summarized it here as having 3 major steps. And the first step is understanding the problem clearly or correctly or completely. And what I'm saying here is we need a problem statement that summarizes everything that we know about the problem, and I'll talk about that in just a few moments. After we're sure that we understand the problem clearly, then we need to identify possible causes. As I mentioned earlier, there are many different ways to do that, and I'll talk about several of them. Once we then identified possible causes, we then need to go out and collect evidence that helps us to confirm or deny each of the causes on that list. And this is actually, believe it or not, an iterative process. We don't understand the problem clearly, identify possible causes, go out and collect evidence to confirm or deny a cause, and then we're done when we go out and find that, yes, okay, this is a machine issue or this is a documentation issue. Then we basically have refined our problem statement, saying now we know that this problem was caused by a piece of equipment or by a documentation issue. We now need to identify possible causes for that equipment failing or that documentation error, and then go out again and collect evidence to determine why that occurred. So this is a very iterative process, which again reinforces the concept of the 5 whys. Each time we ask why, we're basically going through these 3 steps. A good problem statement involves 4 major components. I should have underlined them, I guess, in this first bullet. What, where, when, and how much. Anytime I look at a problem statement that someone is getting ready to work on, an investigation or getting to work on, I'm going to go through in my mind and say, do they know what the problem is? Do they know where it occurred? Do they know when it occurred? And when might include both the specific date and time when it occurred, but it also may ask or say how far back in time has this problem existed, and how much might be frequency, magnitude, and so on. All of these are necessary because without those, we really, for example, don't know how serious the problem may be, which will impact how far we're going to go within our investigation. We don't know whether it's a single event or whether it's a trend, whether it's a shift in performance. And so we really need to spend some time making sure that we have a good understanding of the problem before we even start doing our investigation. So the second bullet says we should look for previous occurrences, because imagine that in this case, or in the case of the problem I mentioned earlier, we only had one lab report that we found that hadn't been signed. But suppose I go back through audit reports from 2 years ago, I may find, well, yeah, actually that had occurred sometime in the past. Now, 2 years ago, I may not pay much attention to, but 6 months ago, I might. So even though during my assessment to develop my problem statement, I may find that I look at the last 2 months and don't see any other examples, I might also want to consider whether or not it might have happened 6 months ago, for example, which might let me know it's more systemic than what I thought. Also, if you have a problem that is sort of cyclical in nature, looking back for previous occurrences is very helpful. Poor understanding of the problem will result in wasted effort. I use an example in my training course where if my dryer isn't working, I ask people what should they do, and many people say, well, gee, let's go see if it's plugged in, or let's go see if the circuit breaker's tripped. And it's my belief that, well, the dryer is not working isn't a good problem statement. It's not sufficiently detailed to let me know what type of a problem I have. And if instead I get a better definition of the problem, such that it did work yesterday versus it doesn't work today, or the problem is related to a lack of heat, or there's no noise at all, lets me know whether or not going to check the power is really going to be worthwhile. Now, my last bullet on this slide is really important. For many problems that we run into in our organizations, let's say non-conforming material, if you're in a manufacturing environment, when we find that, we try to find out how big the problem is and so on, so we do containment. That's not the case in a lot of audits. Very often when we're doing an audit, we may pick up, let's say, a sample of 6 documents or 12 documents and look to see whether or not there's a problem. And if we find a problem in 1 or 2 of them, we simply document that as a nonconformity and move on. So one of the keys here is that audit nonconformities, when they are written up, they are not problem statements. They are not intended to be problem statements. They are only evidence that a problem exists, and whoever's going to do the investigation then needs to, before they even start thinking about causes, need to go back and do a broader assessment of previous occurrences of that problem to see whether or not it's systemic, and then write a problem statement based on that. So even though this sounds like a very simple part of the process, it is the most important part, in my opinion, because a lack of a good problem statement is really going to have us wasting a lot of time. I have 3 examples here. One, and I'm using an example that we had a while ago with someone using an outdated calibration procedure. So one problem statement might be, well, work was performed to an outdated procedure. As you can see, that doesn't tell me anything about where I need to go to start doing the investigation, what type of procedure is, and so on. So it's so horrible that I wouldn't know how to start my investigation. A better one would say, on March the 23rd, a technician performed work to an outdated version of a calibration procedure. Well, now I know that that this probably has to do with the calibration lab, and so I'm going to go into the calibration area and try to find this particular procedure and so on. By the way, notice it says a technician. One thing I should have mentioned earlier is who should never be included in the problem statement when it's someone's name or when it gives you a unique identifier, because even here, if I say a technician, if we only had one technician, people are automatically going to try to blame this technician for this problem. And so be very careful to leave the who out of a problem statement if you can. In this case, if we had multiple technicians, then the word technician simply helps us sort of understand who in the lab was using this procedure. The better problem statement, though, is the third one that says on March 23rd, a technician in the calibration lab performed work to an outdated version of the thermocouple calibration procedure. Notice how much more detailed it is. Which procedure lets us know that it was a C addition versus a D addition. And this is the fourth occurrence of the use of obsolete procedures in the past year in our facility. Not necessarily in the calibration lab, but in our facility. So this says that the use of outdated procedures is not solely an issue in the calibration lab. So we need to look much broader in our investigation rather than focusing just in the lab. Now, had these four occurrences all been within the lab, then I might focus my investigation only there, at least initially, until I see what evidence comes up. Okay, so how do we identify possible causes? Well, in the third bullet, I list things such as lists that we can come up with, such as brainstorming or using a cause and effect diagram. And those are good. They're ways of getting people's ideas. Unfortunately, they don't organize those ideas in a good way that really helps us look at cause and effect relationships. So I prefer to use one or more of the other techniques shown here. One is to use the process flow chart. I used to do a lot of electronics troubleshooting, and it was amazing how useful it was to have an electrical schematic sitting beside me when I was doing that. And I realized after a while that, well, that electrical schematic is really nothing but a flow chart of the flow of electrons through this system. 5 whys is an excellent way to do it, but we need to do that using a diagram that I call a logic tree. Barrier analysis is also a useful method that says, well, in every process we have things that are there intended to be a barrier to keep the problem from occurring or to detect it if it does occur. And so barrier analysis is a very narrow focus solely on those types of issues. And change analysis says, well, if the problem wasn't there yesterday and it is today, what's changed between yesterday and today that might have caused this? So these are 5 different ways to identify possible causes. And we really need to have people in our organizations more knowledgeable about multiple ways of doing this, because it depends upon the type of problem that we have and who's involved with it and so on. Each of these gives us different opportunities for gaining better knowledge about possible causes and also gaining knowledge about the process as we do the investigation. So in my mind, the best 2 methods for identifying possible causes are the flow chart and the logic tree. However, sometimes those will be overkill because it's a very simple problem. The change analysis is only going to be useful if, in fact, there has been a significant change in performance of the system or process that we're troubleshooting. Here is the use of the logic tree and the flow chart for the problem with the use of an incorrect procedure. So at the top, what I've done is to flow chart the process of getting the right procedure into the working database. So what happens is when someone identifies that we have a need for a new procedure or we need to change a procedure, then they create or modify that procedure. That's the second box. Then the third box, someone will review and approve the procedure. It may be the same people or different people. The fourth step is where that procedure gets transferred to the working database. The fifth step is where the old procedure or the obsolete procedure gets deleted from the working database. And then the final box is where the person is gaining access to the procedure at the time that they need it. Now, if we think about each of these steps in the process, some of those could cause this particular problem and some could not. So it could be, for example, if we look at the last step, that the person looked in the wrong database. Or if we look at the step before that, it might be that we did put the new procedure into the database, the working database, but we forgot to remove the old one, so the person grabbed the wrong one. It could be that the transfer simply hasn't taken place yet. It could be that the transfer hasn't taken place because the procedure still hasn't been reviewed and approved, even though we're supposed to be using it, and so on and so forth. So a flowchart is a very useful way to help us diagnose a problem with a process, which any problem in our organization naturally is. Now let's imagine then that we find in this case that the transfer had not occurred, and so that would be the fourth box from the left. What we would do now is to say, okay, now let's flowchart that transfer process and see where in there it failed. So this is how we do sort of a drilling down five whys process using a flowchart. Another way to do it is to use the logic tree, which is sort of similar to a bill of materials. So in this case, I've listed at the top box, it says we've used the wrong edition of the procedure. Well, that could be because the technician did something incorrect, or it could be that the database is incorrect. In this case, it's the database. I would find that out when I go review the database and interview the technician. So I now say, well, what would cause the database to be incorrect? Well, it could be that the new edition had not been transferred, or the new edition had been transferred, but the old edition had not been deleted. Well, we can easily look at the database and find out, well, gee, the new edition is not in there. So then we say, well, why is the new edition not there? Well, it could be that the process for transferring it isn't defined anywhere, so we don't have a procedure for how to do that. Or it could be that we have the process defined in a procedure, but it's not really defined as well as it should be or could be. Or it could be that, yes, it is defined, but somebody just didn't follow for some reason. And again, by doing interviews and so on, reviewing of records, we could find out which of these three caused the problem. In this case, we'd find that the process was poorly defined, maybe didn't take things into account, such as when a full review isn't necessary for a document. And so we would then have that process or that procedure revised. So that's the use of a logic tree to drill down into possible causes. Now, barrier analysis would be, let's say that there's a box at the right-hand side of the flowchart that says that the technician is supposed to review the procedure and compare it to the master list. In this case, that box isn't there, so we can't say that that has anything to do with this problem. If, however, that was an additional box in this process and the person hadn't done it, then that would be considered a failure of the detection step. That is, they got the wrong procedure, they didn't look in the database, they didn't look in the master list to find out that they had the wrong one. And so even though that didn't cause them to get the wrong one, it did allow them to use the wrong one. Change analysis in this case would simply look and say, well, is there anything different? So is this technician, for example, a different technician than in the past? Or have there been any changes to our database? Are we using a different database structure, or different people administering the database, and so on? Change analysis in this case would say, well, the difference between this particular situation and other situations is that it did not require a full review. And so that might help us identify that as an issue. Now, unless we go back and find out what the other occurrences were like and whether or not it's similar or the same, we really wouldn't know whether or not that was an adequate cause. So there are a lot of different ways for identifying possible causes. Which one we will use, again, will depend upon the type of problem we're working on, the knowledge of the people involved, their ability to come together and work to do a flow chart or a logic tree, et cetera, et cetera. And you can, by the way, combine these two very often. So if I said that the fourth step, transfer the approved procedure to the working database, was the cause at the top level, rather than drilling down into that box using a flow chart, I could instead do a logic tree for that particular box. There's a lot of different ways we can use these tools interactively to improve our identification of possible causes. Now, collecting and analyzing data, again, is obviously, in very many cases, the more time-consuming part of the process and difficult. One of the things to keep in mind is that when we mean data, we don't necessarily mean numbers. When we interview someone, that's data. When we're looking at records, that's data. A type of data that I find myself using very often around my home to troubleshoot problems is my senses. So what do I hear? What do I smell? What do I see? So it has nothing to do with data as we would normally think about it, but yet it's a very useful way of figuring out what has caused the problem. Second bullet reminds us, in many cases, it's hard to prove that something actually did cause the problem. And so very often it's easier to identify those things that did not, and then whatever is left over is sort of what we believe is the most likely cause. One of the issues we run into sometimes is people will go look for data that's easy to get rather than saying what's the right type of data to tell us whether or not this particular item is or is not the cause. And so we need to keep that in mind. We need to say what's our theory of cause and effect we're trying to test, and what data will really give us good predictive powers for whether or not that actually did cause it. And then the last one, most of the folks on this at this webinar probably are familiar with histograms, scatter diagrams, run charts, control charts, and so on. All of these tools, pictograms, are very powerful in allowing us to see visually the information that we're collecting, and it's very important to try to do that. So making things visual. I can remember one group I was working with, they were talking about, well, you know, the problem, we saw it for this particular product, we didn't see it for this product, we saw it back then, we're not seeing it now, and so on. And so I said, why don't you just create a table that summarizes what you know about the problem? And it was interesting how once they did that, instead of just talking about these ideas in the air, once they made them concrete, but put them up on a flip chart so they could see and make clear distinctions, it made a big difference. I've talked about this already, that this drilling down is an iterative process. So in this case, imagine that I've ordered a book and the supplier shipped the wrong one to me. They may find that, well, the pick list that they used to pull that book off the shelf is incorrect. And they might find that that's incorrect because the order entry person who created that pick list entered the wrong title. And that might be caused by the fact that there were multiple books with the same title or similar title. And then the real cause would be that our process allows us to take orders based on title only rather than the ISBN number or title plus author's name and so on. So again, just demonstrating that this is not a one-shot deal. Don't expect to get to the cause the first time out. If you do, or if you think you did, there's a good chance that you've missed something. And so what we want to do, my preference is to take a slow, iterative process, drilling down and make sure that I have data to reinforce that I know that something is or is not the actual cause. Time is a big issue we run into with the corrective action process. All too often people are written to their corrective action procedure that we have to have a corrective action within 30 days or 24 hours or whatever it might be. And, you know, I think that really is setting us up to fail. What we need to do instead is to, in each case, allocate an adequate amount of time based on the seriousness of the issue, availability of people, the amount of time that it's going to take to collect the data, and so on. So rather than having a standard time, I think that each time we have a corrective action, we should identify a response time for that particular corrective action. Now, if we have these situations where we do need a quick response, then although I believe it's the process owner who should do the investigations and not the QA personnel, there are times when we need someone with high root cause analysis expertise to help guide the investigation or actually carry it out. But when we use people like that, we need to make sure that we still involve the process owners, because it's their process that is going to need to be changed. So we need to keep that in mind, ownership. And the last slide, importance of culture. Boy, I could go on forever about this, and some recent events in the Gulf of Mexico, for example, would maybe reinforce this. So I simply ask people, what happens in your organization when somebody mentions corrective action? Do people duck their head? Do they treat corrective actions like hot potatoes? That is, what they really want to do is to fill out that sheet and get it out of their hand, or fill out that form on the computer and get it out of their hands so that it's done? Or are they really trying to take their time and learn from it and improve the organization? I still remember Dr. Deming modified the Plan, Do, Check, Act cycle to Plan, Do, Study, Act. And he was really emphasizing that it's all about learning, that when we're studying, what we're doing is finding out whether or not our theories about cause and effect are true or not. And if not, then we can revise those theories based on what we've learned. So, Pablo, I think that's the core of what I wanted to say. You have some questions?
Yeah, thanks, Duke. While we have you here and your 25 years of experience, I definitely think it would be a great bonus for our attendees if you could answer just a few of the top frequently asked questions on root cause analysis. So let me throw a few at you. What do you do if you feel the problem only happens one time, or if there's no data available?
Oh, I always hate it when people ask that question. But it is realistic. I mean, the more that we get into Six Sigma level performance, then the more we're going to be finding problems that don't occur very often. And so one of the things we need to do is to make sure that we have good traceability in our organizations. If we have good traceability back to when a particular action occurred, who was involved with, what piece of equipment, and so on and so forth, then whether it's a single occurrence or multiple occurrences is less critical. So that's one of the issues, is making sure that we have, at least in those environments where failures are, let's say, higher risk, we need to make sure that we have good traceability. Another is to keep in mind that data is almost always available. It's just that it may not be the type of data that we would typically want. So, for example, interview techniques. Interviews are very, very powerful techniques for gaining information about a problem. But the standard interviews that we typically do in audits and so on are not very deep. And if you look at investigations done by, let's say, people that are crime investigators and so on, they have very, very in-depth techniques for helping people get down to memories. Or imagine a hospital, for example, when an operation occurs and it's wrong site surgery. I saw one recently where a lady's leg, the wrong leg was removed.
Oh,
and
gosh.
So, you know, the surgeon and the other people in that room, the anesthesiologists and so on, have been through a lot of surgeries. So, you know, how is it that you expect them to remember this particular one over all the others? And okay, with leg you probably would, but if it's heart surgery or something, you know, they've done so many. But there are techniques that allow us to really help get the person back into that particular operation mentally that are available. Sometimes people call it cognitive interviews. I can't remember the other term. Elicitation techniques. So for people who have problems where there's not a lot of data available, but you think there's information you can get access to if you dig hard enough, I would encourage them to take a look at some things like that.
Oh, okay. Now, you mentioned a lot the people component, the people side of the issues. How do you deal with situations where it's obviously due to human error?
Well, if you believe the corrective actions that I see, about 60% of them are due to human error. But of course, you can't fix human error per se. Human error is simply a category of errors. So if you think about the 7 M's, manpower, methods, material, machinery, Mother Earth, measurements, and management. Those are the 7 cause categories for any particular problem. And so the human is a part of it. However, you can't, if you say, okay, that person made a mistake, you can't fix the problem unless you know why they made that mistake. So diagnosing human error is no different than diagnosing anything else. You have to dig down and find out what was the person doing at the time, what were they thinking at the time, what was the environment like at the time, and is there something about their physiology or their psychology or their senses and so on. There's something about the environment. You know, were they interrupted, for example, by an auditor who came up and asked a question, or was there an alert that went off at the station next to them or something that interfered with them? So it's really no different, except that it's not as easy, if you will, but we still can flowchart the process that the person was doing, the activities they were doing, and drill that down to a deeper level. And we can do a logic tree that considers what the possible causes might be, and then keep drilling down until we get to a level at which we can take action.
Okay. Now, you talked a lot about the process as well. So another frequently asked question is, should we use a team for each investigation?
Each investigation, well, let me rephrase it. Should we use a team for all investigations? The answer is obviously no. Should we use it for each? It depends. You know, there are problems. I mean, imagine the ones that I've talked about, the simple ones I've talked about during this presentation, about the lab report that wasn't signed and the incorrect procedure being used. Well, the lab report non-signed, you know, one person could probably find that cause pretty easily, pretty quickly. So you probably don't need a team. Since we know that we have had incorrect procedures used 4 times across the organization in the last few months, that says this is a sort of systemic issue in our organization, and a team might be useful in this case, involving perhaps IT, the people who develop procedures, the people who review procedures, the people who access the database. And so to me, it really depends upon, you know, how broad is the process, how many different departments, for example, does it touch, how many people are involved in it. Also, what are the risks? Does a single individual have sufficient knowledge to do the investigation and so on? So the answer is some investigations require teams, but definitely not all.
Oh, okay. Well, thank you so much, Duke. That's all the questions that I have. Thanks for contributing your time and knowledge on this ongoing hot topic in quality. Listeners, if you'd like to learn more about Duke Okes, you can contact him via email or phone with the information provided on this last slide. Also, please note that ASQ's Learning Institute offers courses based on the material that we've shared today. There's a 3-day face-to-face course available through ASQ's course clusters, which can also be delivered in-house if anybody's interested. And there's a 12-hour or electronic course available as well. Both of these can be found by searching ASQ's Learning Institute for root cause analysis. To find free and members-only content on root cause analysis, you can also search ASQ's Knowledge Center, where you can find articles, case studies, downloadable tools, webcasts, and more. We thank you for joining us, and we hope to see you at the next event.